Welcome back, class 7. Today we will learn about a phenomena that happens with sound, reflection and absorption of sound. We will start with reflection of sound. Now, as you can experience when you are in an empty room and when you alone speak with yourself, maybe you will hear something called as echo. Now, this is the reflection of sound. Like as I am speaking to you, my sound, I can hear it bouncing back to me. Now this reflection of sound means this reflection happens when sound waves fall on a rigid medium or a rigid surface. Now what's the meaning of rigid? Something which is not flexible, which is strong, which doesn't bend easily. So the walls are made up of bricks, we all know that. Bricks are quite rigid, isn't it? Okay. If sound falls on a closed room where the walls, of course, are made up of bricks, the rigid walls, and they tend to bounce back. This phenomena is called reflection of sound. Okay, sound falling on such a surface bounces back, and we call this bouncing back of sound as echo. Okay, we will learn about echo in detail when we are in class 8. So just learn now that when sound bounces back by hitting a rigid medium means a medium which is not flexible, a strong medium which doesn't bend, then they bounce back. Now usually you must have noticed this. Those houses which are by the roadside, where a lot of traffic is there, they make tall walls surrounding their houses. Now you can think of those walls as a reflecting medium. So when the honking of vehicles and the blaring of motor, they create a lot of noise, isn't it? When they hit this concrete wall, they bounce back. So those who stay inside the compound or inside the house, if they have a wall surrounding their house, then a lot of noise can be minimized when these noises are reflected back by the concrete walls. Alright, so they act as sound barriers. These walls, concrete walls, they act as sound barriers. So this is reflection of sound. Next we will learn is when sound are absorbed, when sound waves are absorbed, absorption of sound. Alright, next is absorption of sound. Now unlike reflection, sound waves, if they happen to hit an unrigid surface, unrigid is opposite of rigid. If rigid is not flexible, so unrigid means flexible. Okay, flexible surfaces are soft surfaces which can be bent, and they are porous. Porous means they have gaps for air to enter in it. Okay, those surfaces are called porous. So, if sound hits such a surface, then what will happen is, let's discuss it. I have written down. Sound waves, they carry energy. We all know sound is a form of energy, right? And this energy is in the form of heat energy. So this energy, when it hits the flexible surface, it enters the porous surface, the porous medium. You know, we have those gaps, small gaps. So the sound enters that gap and it gets trapped within that gap. So much of the sound's energy becomes trapped in the porous surface. So much of the sound's energy is absorbed by the surface, and there is hardly any energy left in the sound to reflect back. So in absorption of sound, we will not hear the echo. You will experience this absorption of sound if you have ever entered in a theater, alright, or cinema hall. In cinema hall, if you have echo happening, you know, we have loudspeakers in a cinema hall, isn't it? So 3-4 loudspeakers, front, back, on the sides, if they start echoing, you will not understand one word spoken, because all the words will echo and it will create a tandem. Okay, confusion. So we need such a room where this echo doesn't take place. So these auditoriums, these theaters and cinema halls, the walls of the cinema hall are lined with either thermocool sheets or thin layer of wood, plywood you can say. Now both thermocol sheets or plywoods, they are porous, they are flexible, so when sound hits the wall which is lined with these linings, the sound will be absorbed and the echo is minimized. That's why it is so clearly heard. The sound is so clearly heard in theatre, in a cinema hall without any echo. But you must have experienced in our auditorium, school auditorium, we don't have any thermocol lining or plywood lining in the walls. So if any movie is shown or if somebody speaks on the loudspeaker, sometimes there is echo happening and what is spoken is not heard properly. Also in an empty room, only the walls are there, and if you speak like how I am speaking right now, you will hear this reflection of sound. But if the room is filled with furniture or people, people are also flexible, right? So when sound falls on people, the sound tends to be absorbed by them also. If it is a full room with furniture and people, then we don't hear this echo, because in such a room you have this sound absorption taking place. But if it is an empty room where only the four walls are there, walls are rigid medium and reflection takes place, so we hear our own echo. And maybe sometimes if we speak very fast, then the sentence is not clearly audible also. Alright, so absorption happens in a medium which is unrigid, that means flexible medium, whereas reflection happens in a rigid medium which is not flexible. In absorption of sound, what happens? The energy of the sound carries energy, right? That energy is trapped within the porous medium of the wall of the medium, and much of the sound which is needed for it to reflect back is absorbed by that particular medium. So we don't have much reflection taking place. So for absorption of sound, we need porous, flexible medium. For reflection, we need a rigid medium. In a forest, thick forest area where lots of trees are there also it serves as sound absorber. If you shout over there, maybe your sound will not be carried over a long distance, because your sound will be absorbed by the linings of the wood. Wood is porous, so it will absorb the sound. Alright, so this completes our topic of absorption and reflection of sound. The last topic for this particular chapter is speed of sound. Now sound requires a medium, and as I had shown you a video where it is proved beyond doubt that sound requires a medium. Remember that bell jar experiment? Okay, in that experiment we had seen that if all the air is sucked out from a bell jar and there is a bell inside the jar, if it rings also from outside, the noise of the ringing is not heard. So sound requires a medium. But the medium, the more denser it is, faster the sound will travel, because sound needs vibration of the particles of medium, and for that molecules are necessary. If there are more number of molecules, then sound will travel even faster, because more number of disturbances will be there. So in solids we have the maximum density of molecules. Solids are densely packed, so there are more number of molecules in a solid medium. So sound travels fastest in solids. Next is liquids. Now in liquid the molecular density is lesser than in solids. So the speed of sound will be lesser than what it is in solids. And in gases the sound will travel with the least speed, because in gases we have molecular density the least. Okay, in a given amount of volume, the number of molecules in gases is the minimum that we all know. So fastest is in solids, slower in solids it happens in liquids, and in gases it is the slowest. So you have a table in your book, page number 61. Here it is, page number 61. This particular table shows you the speed of sound in all the three mediums. you have, first they have given all the gases, air, carbon dioxide, hydrogen, oxygen, helium. There the speeds are given. Then you have liquids. In liquids also, different types of liquids are given, and the velocities of sound is also mentioned over there. And finally in solids. So you will see that in all the solid mediums, the velocities of sound are more than liquid, and in liquid medium the velocities of sound is more than that is in gases. Alright, so this completes our chapter, and I expect you all to just revise whatever is taught, and very soon we will start with the next chapter.